Preparation of aldehyde and ketone is a common methods to synthesis aldehyde. Okay, that meaning this the famous method here to prepare aldehyde. But there is another method. Okay, but this the common method for synthesis of aldehyde. We'll take the aldehyde and then the ketone because the aldehyde different from the ketone by using the starting material. Okay. For example, here we used primary alcohol, but for the ketone we use the secondary alcohol. Now, the first method he said by oxidation of a primary alcohol with pyridinium chlorochromate. This the pyridinium chlorochromate here. Okay. This oxidating reagent can be convert the primary alcohol to the aldehyde. Okay, this the abstract here, the pyridinium chlorochromate, PCC. Okay, this is the first method. But the mechanism, how the mechanism, we don't take the mechanism for this reaction. It's slightly difficult for graduate students. Then it is enough for us to prepare the aldehyde just from primary alcohol by using pyridinium chlorochromate. Memorize this, okay? The second method by, look, here by oxidation, here by reduction, reverse, by reduction of ester, okay, and acid chloride. We have here ester, this ester R, C double bond OOR, this is the ester functional group, and the acid chloride. For the ester, we use DiBal hydrate, okay, diisobutyl aluminum hydride. This is a reduction reagent and not very strong reduction mild. We said mild reduction reagent, okay, mild, not very strong, not like aluminum lithium hydride. Then it's by two steps. The step number one, diisobutyl aluminum hydride. Step number two, hydrolysis with the H2O to convert the ester to the aldehyde. From the acid chloride, this is the acid chloride, okay, by using this reagent, okay, also it is mild reagent, not very strong. The step number two, it will be hydrolysis with water to give you the aldehyde. And I will give you the structure for this two reagents in the next slide. This is the method number two, okay, reduction. And the method number three, it is not new for you, this. You know this method, hydroboration, oxidation of an alkyl. You take it before that. Step number one, hydroboration. Step number two, oxidation by using peroxide hydrogen. This is the peroxide hydrogen to give you aldehyde, but not, the first structure it not be aldehyde, it will be enol, if you remember that. And we have tautomerism to give you the final product, to give you the keto form, okay? That it will be enol, the first figure, and then it will be give you keto form by using tautomerism. You know this reaction. Okay. This take this. We said before that diisobutyl aluminum hydride, okay, the مختصر أبيات is it will be like this, has two bulky isobutyl groups. This, okay, look, this is two bulky isobutyl group. Okay, what is the work of this two big group here? Make this reagent less reactive than lithium aluminum hydride. Okay, that meaning this less reactive than lithium aluminum hydride. If you use lithium aluminum hydride, maybe don't give you here. Maybe don't give you aldehyde. It will be give you directly, maybe give you carboxylic acid, another compound. Okay, then it will be further reduction here. It will be further reduction. Okay. But this, no, it will be here. Sorry, I'm talking about here. It will be further reduction. But here we use mild reduction agent. Okay. less reactive than lithium aluminum hydride. Okay, he said here, look, we just have single hydrogen atom is donated as hydride. We said before hydride. This hydride minus, hydrogen minus, it will be make reduction for the compound to convert to the aldehyde. Okay, the second one, this. Okay, the second one, this. Lithium, we have lithium. Okay, try this 1, 2, 3. Try tertiary butexy. This is butexy. Try tertiary butexy. 1, 2, 3. 3 group. Try tertiary butexy aluminum hydride. Okay. Also, this has a 3 electronegative oxygen atom. Look, 1, 2, 3. 3 oxygen atom. This 3 oxygen atom with high electronegativity. We know that. Okay, bonded to the aluminum. Okay, if this 3 oxygen atom bonded to the aluminum and all this group is withdrawing group, make this reagent less nucleophilic than the lithium aluminum hydride. Okay, it will be weak nucleophile. Okay, for this reason it will be less reactive than lithium aluminum hydride. It will be mild reagent. Okay. Take this example. What is the difference if you use lithium aluminum hydride? If you used mild reduction reagent like lithium tertiary butoxy aluminum hydride? Okay, take this acetic chloride. Okay, this is acid derivative from the acetic acid, and it will be react with strong reducing agent lithium aluminum hydride. طبعا 2 step, and step number 2 it will be hydrolysis to give you, look, primary كحول. This strong reduction. Okay, this reduction is a strong process here. But take this, the mild reagent, no, it will be give you aldehyde. طبعا aldehyde, if you make further reduction for the aldehyde, it will be convert to the alcohol. Okay, that meaning aldehyde further reduction give you alcohol, but we don't want alcohol. We want aldehyde from the acetic chloride. Okay, for this reason we used mild reduction agent. عامل مختزل ضعيف, not very strong. Okay, to stop enter here, to stop enter aldehyde. Look at this ester, strong reagent. Okay, strong reducing agent here, ester. Give you كحول, also كحول, but mild reducing agent give you aldehyde. طبعا aldehyde further reduction give you كحول. Okay, further reduction, aldehyde can give you alcohol as a product if you make further reduction for the aldehyde. Okay, for the ester, look, for the ester we have side product here. This it will be leave the structure as methanol. Okay, this side product. But this the main product, ناتج الرئيسي, وهنا عندنا ناتج جانبي. This about aldehyde. طبعا the same thing for the ketone. We have oxidation, reduction. Also we have Friedel-Crafts acylation. You know this procedure. Okay, you know this procedure. Also the mechanism. It is clear for you. Acylation for the benzene compound. Also by hydration of an alkyne. Also you know this the reaction. Reaction. Also it will be give you enol form, and the enol form by tautomerism it will be convert to the keto form. Okay, the same thing. But here the oxidation we used طبعا secondary alcohol. This not the primary, because the primary give you aldehyde. But the secondary alcohol, the OH group bonded to the secondary carbon. That meaning we have 2 alkyl group, 1, 2. And this, it will be here double bond to give you a ketone. Okay? If you use a primary alcohol, the OH bonded to the primary carbon. Primary carbon, just 1 alkyl group. That meaning it will be give you aldehyde, not give you ketone. Okay. طبعا by using the chromium reagents, all the reagents with the chromium metals, we have many different reagents here. We have CrO3, we have Na 2Cr2O7, we have K2Cr2O7. All this also we have the PCC. All this is oxidation agent, can be converted secondary alcohol to the ketone. طبعا طلبة this without mechanism. Just I want from you to memorize this. If you look, I give you CrO3, look, all this reagent and this reagent and this reagent with high oxygen atom. Look, 7 oxygen atom, 3 oxygen atoms, okay? That meaning this oxidation agent, okay? For this reason, I want from you to memorize this. Just if you used oxidative agent with secondary alcohol, give you the ketone. Okay. The second reaction by reaction of acid chloride, this acid chloride, okay, with organocaprate, okay. This is the organocaprate here. طبعا طلبة this it is like a Grignard reagent. If you know the Grignard reagent, RMGX, okay, here the same thing. The work of this is source for the alkyl nucleophile, alkyl group, okay. This alkyl group as nucleophile, it will be attack the carbonyl, and the chlor it will be leave, because we know the chlor, the halogen is good leaving group, okay. That meaning it will be happen here. What happened? It will be happen replacement, substitution. Okay. Then this is agent is source for R minus. Okay. R minus يعني nucleophile. Okay. Maybe CH3 minus, maybe CH3 CH2 minus. يعني alkyl minus. Okay. Alkyl minus group. It is do as nucleophile, can be attack any electrophile, and our electrophile here we said before that the carbonyl for the ketone and aldehyde carbon, it will be partially positive, okay. That meaning it is easy from the nucleophile to attack the carbon, and the halogen it will be leave the structure as leaving group, okay. The third reaction, we take it before that. Also, it is easy for you, and I hope you know the mechanism. Okay, is a Friedrich-Kraft acylation. The acyl is a electrophilic substitution reaction on the benzene compound. Okay, and to be give you aromatic ketone compound. This aromatic ketone. Okay, this aromatic ketone, and the final one is by hydration of an alkyne to give you enol by tautomerism, give you ketoform. And also you know this, if you don't remember this reaction, you can go back to the reaction of alkyne. Okay, reaction of alkyne, I think chapter number 4 for the first semester, and you have all the mechanism for this reaction. Aldehyde and ketone are also both obtained as a product from the oxidative cleavage of alkene. Okay, that meaning we have alkene. This alkene can be cleaved to 2 parts, this part and also this part. Okay, by analysis with ozone. Okay, التحلل الأوزوني. Here the main product, look, the main product, make this 2 parts. This part, it will be bonded with oxygen. Also, this part, it will be bonded with oxygen atom. Okay. The mechanism also, it is so complex for you. We have here pericyclic compound as intermediate, and we have rearrangement for all this for the mechanism. And finally, it will be give you the product after reaction with the zinc H2O or the mercaptan compound. This is the mercaptan compound, CH3SCH3. It is like ether, but this compound called mercaptans. Okay, then the mechanism is so complex for you, but I want from you to know the alkene can be converted to the aldehyde and ketone by reaction with the ozone analysis, التحلل الأوزوني. Okay, by this reagent. This just I want from you to memorize this. If I give you ozone gas and alkene, you will be know it will be the alkene will be cleaved to the two parts, and every part it will be bonded, this part and this part, every part it will be bonded with the oxygen atom as final product. Okay. Then look, if we have here R group and we have hydrogen R group, that meaning this part give you ketone and this part give you aldehyde. Okay. If I give you starting material here hydrogen, that meaning both the product it will be aldehyde. Okay. Aldehyde. If I give you alkene with 4 R group, 1, 2, 3, 4, that meaning both the product it will be ketones without aldehyde. That meaning the product anytime it will be give you ketone, anytime it will be aldehyde, dependent on your starting material. Okay, dependent on your starting material that you use it for the ozone analysis. Now he said what reagents are needed to convert each compound into butanol. Okay, into butanol. That meaning this compound it will be converted to the aldehyde, butanol. Look, aldehyde. This compound give you aldehyde. Any reagent, any reaction, this compound give you aldehyde. This compound give you aldehyde. Write the structure and think about the reagents that possible to use here. Okay. Also easy, not so difficult. What reagents are needed to convert each compound into acetophenone? Look, this ketone. That meaning how the benzene will be converted to the acetophenone. How this compound will be converted to the acetophenone. How this compound will be converted to the acetophenone. Okay. Also this homework for you. Try to resolve by using suitable reagents. And reaction of aldehyde and ketone, here general consideration. طبعا aldehyde and ketone we have functional group for the aldehyde and ketone. It is the carbonyl group. Here this the carbonyl group. This our functional group. Okay. He said from here, from this chapter, that uncrowded electrophilic carbonyl carbon. He said this carbon here, it will be uncrowded, yani without steric hindrance. Okay. And he said electrophilic, that meaning it will be positive or partially positive. Okay. For this reason, this carbon make aldehyde and ketose, okay, susceptible, يعني suitable to the nucleophilic addition reaction. طلبة, look here, be careful. Nucleophilic addition reaction. Okay. Nucleophile, that meaning the nucleophile, it will be attack the electrophile. That meaning we cannot use electrophile here. Okay. The name of this reaction, look, nucleophilic addition reaction. That means the nucleophile will be attack the carbon. And what will be happened? It will be happened addition, not replacement. Okay? يعني not substitution. It will be addition. Addition, it is different from the substitution. Substitution meaning replacement, تبديل. Remove a group, put another group. But here no, addition. Okay, يعني added a group without remove a group. Here the different. Nucleophilic addition reaction. Be careful about this. Okay, nucleophilic, because also we have nucleophilic substitution. We have electrophilic substitution, and this, and also we have electrophilic addition, but this is nucleophilic addition. Okay, this is nucleophilic addition. Look here, we have nucleophile. Okay, if you used full negative charge nucleophile, طبعا this nucleophile will be strong, very strong nucleophile. That meaning you need to additional step is the use water, okay, to give you the product. But if you use neutral nucleophile, you don't need to the additional step, the treatment with water to give you the product. We'll take the mechanism, okay. Here, look, use nucleophile. This nucleophile, it will be attack this carbon. Okay. When this nucleophile attack this carbon, the pi bond, it will be open on the oxygen. It will be negative. Okay. In this case, we have leaving group. No, we don't have leaving group. This leaving group, hydrogen. No, it is not leaving group. The R group leaving group. No, it is not leaving group. For this reason here, we don't have any substitution. It will be just addition. Okay. The second step, we have hydrogen, oxygen minus. Oxygen minus take proton from the H2O to give you the final product. Okay. طبعا final product, it's come from the addition, nucleophilic addition. And طبعا this the first one. The second one, reaction at alpha carbon. That meaning here, number one, reaction at the carbon of carbonyl. The second one here, no, reaction at alpha carbon. طبعا because of the carbonyl, the carbonyl group is withdrawing group, not donating. Okay, make the hydrogen here at alpha, here the alpha, beta, gamma. Okay, make the hydrogen at alpha carbon acidic. Okay, make the hydrogen at alpha carbon acidic. For this reason, if you have any base, the base can be react with the alpha hydrogen, remove it, okay, to give you anion, and the anion, it will be go to the further reaction. I will explain for you this here. A second general reaction of aldehyde and ketone involve reaction at alpha carbon. Okay, you know the meaning, what meaning the alpha carbon. Okay, the alpha carbon meaning the carbon directly bonded to the carbonyl group. Okay, and the carbon hydrogen bond on the alpha carbon or the carbonyl is more acidic than many other carbon hydrogen. We know that. Because the reaction with base form a resonance stabilized enolate anion. Okay, here, look, this the alpha carbon. The base attack with the hydrogen of the alpha carbon to give you enolate. This enolate is stable? Yes, stable. That meaning with this, it will be make double bond, and this, it will be open. That meaning we have two resonance structure. Okay, for this reason, it will be stable. Okay, this enolate nucleophile can be react with any electrophile. Okay, with any electrophile to give you substitution on the alpha carbon. This alpha carbon, we have substitution on the alpha carbon. Okay, this here substitution. Why substitution? Okay, because we remove hydrogen, and the total result of this reaction, remove hydrogen, put a new group. Okay, that meaning this reaction here, it is not addition, it is substitution. Aldehyde and ketone react with nucleophile at carbonyl. Carbon, aldehyde, and ketone form enolate that react with electrophile at alpha carbon. Okay, that meaning we have two possible way how the aldehyde and ketone can be react. Okay, the first one, react on the carbon for the carbonyl group. The second one, react on the alpha carbon. Okay, to give you enolate, and the enolate, it will be react with the electrophile. Okay, now the mechanism for the nucleophilic addition. Look, we have nucleophilic addition now. Nucleophilic addition. Okay, we will take the mechanism. Look, the general mechanism are usually drawn for the nucleophilic addition dependent on the nucleophile. Negatively charged versus neutral. That meaning, this your nucleophile, it will be full negative charge or it will be neutral. Okay, and the presence or absence of an acid as catalyst. Also, sometimes we can use here acid as catalyst for the nucleophilic addition. Okay, with negatively charged nucleophile. Okay, with negatively charged nucleophile addition follow the two-step process. First discussed in chapter, we know that the nucleophile, I give you the mechanism now, followed by, that meaning it will be nucleophilic attack, followed by protonation. Okay, where is here? Look, nucleophile attack the carbon, give you negative charge on the oxygen, and there a protonation. Protonation, that meaning the negative charge, it will be take a proton from the water. This process, protonation. Okay, this process, protonation. Look to step number one. The step number one, nucleophilic attack the carbonyl group. Okay, the pi bond, it will be clear. Okay, and both of the electron for the pi bond, it will be moved to the oxygen to give you oxygen negative charge. Okay, the second step here, a protonation of the negatively charged oxygen atom by H2O. What meaning of protonation? يعني take a proton, add the proton. Okay, proton. What meaning of proton? Meaning hydrogen plus. Okay. That meaning the oxygen, anshap of electron on the oxygen, it will be attack the proton from the H2O. This process called a protonation. Okay, and this is the mechanism. Okay, addition, protonation. Okay, and this mechanism, nucleophilic attack precedes protonation. Yes, we know. Nucleophilic addition and then a protonation. With some neutral nucleophile, if you use neutral nucleophile, okay, the neutral nucleophile is not strong. Okay, however, nucleophilic addition doesn't occur unless an acid as catalyst used. Okay, now this is nucleophile with negative charge. That meaning is strong nucleophile. Okay, what will be happened if you use neutral nucleophile like كحول? Okay, like كحول, like H2O. Okay, that meaning the neutral nucleophile is not very strong, cannot be attack the partially positive charge. Okay, for this reason, in these cases, if you use neutral nucleophile, you have to use acid as catalyst. Okay, the acid, what will be doing here? It will be doing a protonation. It will be doing protonation and then nucleophilic attack. Okay, without catalyst, if you use strong nucleophile with negative charge, it will be happen nucleophilic attack and then a protonation. But if you use neutral nucleophile, no, it will be happen the protonation because we use acid as catalyst and then nucleophilic attack. يعني عكس بالضبط, reverse طلبة. Nucleophilic and then protonation. Here with acid, no, protonation and nucleophilic attack. Okay, be careful about this. Look to the mechanism. This is the mechanism. Okay, now look at the mechanism. The mechanism, if you use neutral, look, this is a neutral nucleophile, not very strong. Okay, weak nucleophile. Okay, weak nucleophile, that means cannot be attacked here, a partially positive charge. Okay, we use catalyst. Look, general mechanism, acid catalyst, nucleophilic addition, catalyst, acid. This now is base or acidic? No, it will be base. Why? Because we have unshaped electron on the oxygen. Okay, we have acid. That meaning the unshaped electron, it will be attack the proton of the acid, remove the proton from the acid. This process is a protonation. To give you what? To give you OH plus. How we can remove this positive charge? طبعا by resonance. By bond, it will be open to here, and the positive, it will be converted to here. Now we have OH and full positive charge. Full positive charge is easy. The nucleophile can be attacked the full positive charge, okay? Because this full positive charge, very strong electrophile, is easy to attack from the neutral nucleophile. The neutral nucleophile attack the full positive charge, the carbocation here, carb anion, carb cation, sorry, not anion, carb cation, the carbocation. Okay, and give you this intermediate with positive charge on the nucleophile. That meaning we have this here, the minus part from the acidic. It will be remove the proton from the nucleophile group to equal this positive charge and finally give you the product. Okay, protonation, nucleophilic attack, and deprotonation for the substituted group. Okay, protonation and then nucleophilic attack. But if you use strong nucleophile, it will be nucleophilic attack and then a protonation. be careful about this. Okay, that meaning we have two possible mechanisms. The first mechanism, the mechanism. I will go back. The mechanism if you use strong nucleophile. Okay, this mechanism if you use weak nucleophile. Okay. طبعا we said here, I explained for you before that, the effect of the protonation to convert the neutral carbon, this neutral carbon or partially positive, to one having negative positive charge, net positive charge. That meaning this, it will be positive charged here, and then by resonance, it will be give you full positive charge. The working of acid here. This protonated carbonyl group is much more than the electrophile and much more susceptible to the attack by nucleophilic, is more suitable for attack by nucleophile. This step is unnecessary with strong. Look, this step is unnecessary with strong nucleophile. يعني إنها ضرورية. قال كي قال strong nucleophile. If you use weak nucleophile, no, you have to put as catalyst acid. But if you use strong nucleophile, this strong nucleophile, you don't need it to add catalyst. Okay, like hydride that we'll use it in chapter, yes, in another chapter with weaker nucleophile. However, the nucleophilic attack doesn't occur unless on the carbonyl group is the first protonated. That meaning a protonation will be happen, and then the attack it will be happen on the carbon of the carbonyl group. Okay, any reaction involve carbonyl group and strong acid being with same first step. That meaning if I give you any carbonyl group and you saw with we have acid, that meaning the first step it will be protonation. Okay, it will be protonation for the carbonyl group. What we have here, we have the nucleophilic addition of reaction, and then this chapter طبعا it will be finished. Nucleophilic addition. Okay, I will stop here طلبة. This enough for you today, and next chapter inshallah next lecture, this chapter it will be finished, and read again, listen again to this lecture. If you have any question, can you ask me? If you don't have any question, you can take your time, and see you.